Analytical study of single-skin steel tube confined reinforced concrete columns exposed to different fire conditions. Abstract steel tube confined reinforced concrete, Stcrc, columns, are a kind of composite column in which the outer steel tube acts predominantly as hoop reinforcement. This is achieved by the provision of breaks to the longitudinal continuity of the steel tube. In this arrangement, better confinement effect is offered by steel tube to concrete, which enhances the strength and ductility of the infilled concrete. This reduces the chances of local buckling and increases the fire resistance. This paper highlights the performance of single-skin Stcrc column under fire exposure. Such columns consists of a steel section, in which the reinforced concrete is cast. The load-carrying capacity of single-skin Stcrc column without fire exposure and with fire exposure for 60-minute and 120-minute retention are compared with that of RC column. The results obtained from this study have shown that single-skin Stcrc columns offers better load-carrying capacity than the conventional RC column, when exposed to fire. Keyword: single-skin Stcrc column, fire exposure, load-carrying capacity. Introduction. RCC and steel frames have been the most common frame systems for long times, whereas composite frame system has also emerged as popular system for high-rise buildings for few decades. Multi-story composite frames are generally composed of structural steel members made composite with concrete. A type of reinforced concrete columns confined by steel tubes are known as steel tube confined reinforced concrete, Stcrc, columns. This type of column is achieved by the provision of breaks to the longitudinal continuity, gaps, of the steel tube. They are a kind of composite column in which the outer steel tube acts predominantly as hoop reinforcement, and such columns exhibits high load-bearing performance. The breaks present at the member ends limit the longitudinal stresses in the steel and maximize the level of confinement afforded to the concrete through the generation of hoop stresses in the tube. Thus, the steel tube is pressure-free from the longitudinal force and applies a considerable radial constraint to the concrete, which consequently increases the strength as well as the ductility of the concrete. 2. Literature review. The performance of Stcrc columns subjected to standard fire conditions was evaluated to determine the fundamental behavior of these columns in fire and obtain essential information to underpin their fire safety design. Stcrc column with beam connection is shown in Fig.1. In order to prevent load being applied to the tube directly, the steel tube is usually terminated at the beam to column connections rather than being continuous, thus reducing the chances of local buckling of the steel tube in Stcrc columns. Fakailu et al. Presents the results of an experimental study on Stcrc columns exposed to fire, and it was observed that, despite some crushing occurred in concrete, the concrete remained largely intact due to the confinement of the outer steel tube, which prevented falling off of the concrete cover. 1. Fakailu et al. Conducted experimental and numerical study on the behavior of Stcrc columns after fire exposure and concluded that longer heating time results in lower residual load-bearing capacity and compressive stiffness due to decrease of strength and elastic modulus after fire exposure. 2. Huayang et al. Investigated the fire behavior of such columns and found that the temperature was not uniform across the cross-section and decreased from the outer steel tube to the concrete center. 3. The delay of temperature rise is attributed to the high thermal capacity of concrete and the protection from the surrounding material. In the post-fire behavior study of columns, all the specimens exhibited a fairly ductile behavior on exposure to longer heating times and hence the possibility of rehabilitation. 4. In this study, the performance of single-skin Stcrc column under fire has been investigated. Fig. 1. A schematic view of Stcrc column. 1. 3. Numerical study on single-skin Stcrc column. Single-skin Stcrc columns consists of a steel section and the reinforced concrete is cast in between the steel section. The fire exposure to the specimens is as per ISO 834, ISO 1999, standard fire curve. The analysis of columns were done using ANSYS 16.1 workbench, a finite element software for mathematical modeling and analysis. The analytical study includes the development of finite element model to evaluate the performance of single-skin Stcrc column, at different fire exposure times. Single-skin Stcrc column specimen is circular. Outer diameter of the single-skin Stcrc column is 300 mm and steel tube thickness is 2.75 mm. Length of specimen is 3,770 mm with concrete cover of 25 mm. The reinforcing cages were fabricated by tying 8 longitudinal reinforcing bars with stirrups at intervals of 200 mm. The diameter of longitudinal bars and stirrups were 20 and 6.8 mm respectively. The specimens were fixed at the bottom end and pinned at the top end. The material properties, Table 1, 2, and 3, were assigned to the models and analysis of columns has been performed under normal condition, fire exposure condition for 60 minutes and 120 minutes. The exposure time were chosen for the ease of solving. The reinforced concrete column was modeled with the same dimensions to that of the single-skin Stcrc column, except there was no steel tube in the column. The outer diameter, length of column and the reinforcing bars were same as that of single-skin Stcrc column. For results and discussion. The results of numerical analysis such as load carrying capacity and deflection of single-skin Stcrc column and RC column are shown in Table 4 and 5. Load carrying capacity of single-skin Stcrc specimen under normal conditions shows 3,101.3 knots, whereas that of RC column shows 1,954.2 knots, which is 60% lesser than that of single-skin Stcrc column. The deflection of RC column is more than that of Stcrc column under normal condition. The single-skin Stcrc specimen withstand up to 972.170 C when subjected to fire exposure for 60 minutes and shows a reduced load carrying capacity of 2,594.4 knots with 20.07 mm deflection. The load carrying capacity of RC column reduced to 1,850.70 knots and deflection increased to 24.79 mm at 60 minutes of fire exposure. Under fire exposure for 120 minutes, single-skin Stcrc column shows load capacity as 2,565.2 knots at 1,079.60 C and deflected to 22.79 mm. In case of RC specimen, only a small reduction in load capacity is observed, 1,848.20 knots with a deflection of 24.39 mm, compared to that at 60 minutes fire exposure. The load deflection curve of Stcrc and RC columns is shown in Fig. 2 and 3 respectively. Temperature distribution in Y direction can be visualized in Fig. 4, 5, 6 and 7. V. Conclusions. Present study evaluates the performance of single-skin Stcrc column, at different fire exposure conditions and compared with RC column. Tests on specimens with boundary conditions of bottom end fixed and top end pinned through numerical analysis. The load carrying capacity of single-skin Stcrc column was observed higher than that of RC column. The deflection of single-skin Stcrc column was lower than that of RC column, when it is exposed to longer heating times. The main conclusions are summarized as follows. In normal condition, load carrying capacity of single-skin Stcrc column is 3,101.3 knots with 18.5 mm deflection and that of RC column is 1,954.2 knots with a deflection of 24.11 mm. Under fire exposure for 60 minutes, the load carrying capacity of single-skin Stcrc column was observed as 2,594.4 knots at 972.170 C and that of RC column as 1,850.7 knots at 945.040 C. During 120 minutes of fire exposure condition, Single skin Stcrc and RC column show reduced load capacity as 2565.2 knots at 1079.60 C and 1848.20 knots at 1049 C respectively. Single skin Stcrc column shows high load carrying capacity with low deflection compared to conventional RC column when subjected to such extreme temperatures.